Let's talk about the 20 by 4 LCD, that industry standard LCD that we want to use in our project as an amplifier front panel, which provide a better display than a single LED that will convey more information as alphanumeric. And I want to change a little bit of the process by reducing circuit and program explanation here in episode 7. And I'm going to point a document that further explain the use of the circuit and the program driving it. So if you are interested to know more, let me know and I can send it to you, or find the link below on the description. Hi, my name is Ferdinand and my friends call me Dandy. I'm a raw DIYer in electronics, designing my own circuit, writing my own programs, and building electronics projects. I love my hobby. It's a powerful source of personal achievements, happiness, and self-fulfillment. And here is a series of videos I created, so go on, keep watching and learn about this project. Thank you for watching. So how I interface this 20 by 4 LCD into the micro? My source of information is the BASCOM 851 reference manual, which recommend the LCD hardware interface on page 228. Take a look at that, and the way it is connected to the micro is in the 4-bit mode, wherein there are 4 bits data bus, the DB7 to DB4, and there will be 2 control bus. They are the enable and register select, or RS. From the given information on the BASCOM reference manual on page 228, I can interface the data bus and control bus into our STC90C516RD bus micro as per the I/O mapping table. This I/O mapping table is an designation of micro port, which one to connect to the control bus and which one for the data bus. And the resulting schematic diagram, it looks like this. One important thing to know in the schematic diagram is the VR10, which is used to adjust the contrast for a better viewing. The LCD module comes with the backlight, and this can be imagined as several LEDs inside the 20 by 4 LCD module, and it requires a transistor to drive these several LEDs. The backlight is driven by port P2.3 based on the I/O mapping definition, and the initial state is logic 1, which means the backlight is turned off initially, and by applying a logic 0, will turn on the backlight. For the program, I highly suggest that you watch episode 3 to understand more of the software discussion. You should have a copy of the program 06 in episode 3, which is just an LCD simulation. Again, find the link below and download the program exercise as well as the schematic diagram. To have Program 6 simulation to run in the real hardware, I updated that to Program 9.0, a 20 by 4 LCD in the real hardware. Let's compile and download the program, and there you go, the display on the LCD. Welcome to Baguio. Welcome to Baguio, the Philippines. It looks very simple, right? It's really straightforward. It's not a complex thing to do, and that is good for us that we can easily manage it. Let me see if I'm going to combine all the MMI hardware like the buzzer, the LED, the switch, and now with the LCD for a better man-machine interface between the user and our project. Basically, it's the same program as in program 8, wherein you will going to press S9 to make the LED blink with further sentence on the LCD display that can be read by the user, and I call this as a program 9.1, and this is our program 9.1, which simply means all the MMI hardware will be used. And the real world output of the program will be like this, running on its real hardware.